Hello everyone to the lecture of analysis of algorithm. This is our lecture 2 and we cover some topic in lecture 2. First we talk about deterministic problem. Deterministic problem, those problem we follow the same path. For example, this is your home. This is your home and this is your school. And there is a road you can follow regular time, and this is only one road to go to your school. So this type of problem is deterministic problem. So talk about more details. Let's see. A deterministic problem is like following a recipe where every step is clear, defined, given the same input, the same output is always procedure. There are only one path to follow at each step. Imagine baking a cake with a strict recipe at 2 eggs, steep 2 minutes, bake 180 degrees Celsius and bake it for 30 minutes. Every time you follow this step, the same cake comes out. It did not depend on the number of quantity. If you increase the number of quantity, the size of cake is increasing, but the overall architecture of this is same. Algorithm solve it by making only one decision at each step without guessing. Example: binary search. It deterministically checks the middle elements and narrow down the range. No guessing. You know that binary search, if there is a number of set, then we divided it, then check the number is here or the number is here. If the number is here, we cut this, then again we divided this, then we check number is this side or this side. That's way binary search work. So this is a deterministic problem because the procedure of this problem is same. Non-deterministic problem is opposite of deterministic problem. A non-deterministic problem allow for multiple possible choices at each step. It's like magic. You can guess the correct path instantly. It's not how real computers work, but it's help us reason about complexity, often used in theoretical models like non-deterministic turning machine. Example analogy. Imagine trying to find a key in a huge pile, but with a superpower, you instantly pick the right one if you magically knew where it was. Decision make in runtime. Example NP problem. So deterministic problem is just like for example, you want to make a cup of tea. You boil some water. Just this is a fire. This is your kettle. This is water. You boil some water and decide to make a tea, but you can make lots of type tea: milk tea, lemon tea, and green tea. You can choose any one because the path is not fixed. We take decision in the runtime, so that is deterministic problem. Decision problem. Definition: a problem where the answer is simply yes or no. So this is very simple. For example, you can for example you say someone that is there a key in the box to open the door. The person obviously reply yes or no. So that's his decision problem. only two outcomes, a list of number and a target sum. As the input we check this a list of number and target sum. If we find the target sum, is there a subset that sum to the target? If there is a yes in the subset, then yes, otherwise no. So this decision problem is very easy and basics. I hope you understand this one. Search problem. Definition: find a solution or an example that satisfies some condition. Uh, for example, you say that which key in the box. In a decision problem, you say that is there a key in the box that open the door? And search problem, then we search the key if there is available. If the answer is yes, then we search the key, and this is search problem, searching something. Counting problem, uh, count how many solutions satisfy a condition. Let's example, you there are lots of key in the box and some of the keys are used to open the door. Then you counting that how many key can open the door. So this type of problem is counting problem. Now let's talk about optimization problem. Definition: find the best solution according to the sum matrix. You can use max, mean, shortest. Which key open the door fastest or with less effort? We have to find the best solution, best one solution. This is optimization problem. Polynomial time. Definition: an algorithm run in polynomial time if its running time is upper bounded by a polynomial function of the input size, say n square into the power cube. For example, output time is output time is into the power, let's say something. So this type of problem is polynomial. You know the term with polynomial, that what is polynomial? This is our polynomial. It can be n to the power 1, it can be n to the power 2. That's it. You are sorting a list of n number using merge sort. Times order of log n. Time is better than order of n square. Still polynomial. Think of it as climbing stairs, slow and steady, even if you add more steps. Problems solvable in polynomial times are considered tractable or efficient. Most of the problem we solve in real world, that's a polynomial problem, and it can be solved in polynomial time. Let's talk about exponential. Explosive growth algorithm. Definition: an algorithm run is exponential times if its running time grow like 2 to the power n. So it can be x to the power n. This is, we call this a exponential function. Example: the naive solution to the subset sum problem. Try all subset 2 to the power n possible possibilities. Now imagine doubling your step every second. So you are in the stratosphere. Even small increase in input size makes the computation explode. These problems are incredible for large input. For example, for one input, it's get two step, then for this. So the steps are increasing like this. The more step is increasing, the algorithm take more time to run to find the output. You can see this table, so it's help you to clear your understanding. Visual growth comparison for for 5 input, polynomial time is 25. Let's say second and is 32. When we input 10 times, then it input size is 10, then we take 100 second in polynomial, but this is more than 1000 in 20, that is 400. You can see that the number is increasing rapidly for exponential. So you can imagine or say that the polynomial solution is the best solution for most of the time. We try to avoid exponential solution because it takes maximum time most of the time. Class P. Now let's talk about class P. Problem for which a solution can found in polynomial time. We already know that what is polynomial time, n to the power x. We find solution in n to the power x time. So this is polynomial time. These are problems that modern computer can solve quickly even for large input. I already talked about that in the previous table. Now what is NP problem? Problem for which if someone gives you a candidate solution, you can verify its correctness in polynomial time. So in class P, we can find the solution in deterministic way. We already talked about deterministic. You know that what is deterministic problem. We know that we follow the one path. So in pre class P, we follow deterministic problem or deterministic solution. In NP problem, we find the solution by non-deterministic way, and we verify the solution with polynomial time. So solution find non-deterministic way, and we verify it in polynomial time, say n to the power x. So this is class NP. Basically, all this stuff talk about the same concept. We don't know if we can always find the solution quickly, but if someone hands you the answer, you can check it fast. It's mean you verify this. So that's this NP problem. Class NP complete complete NPC, the hardest problem in NP. Definition: these are the hardest problem in NP. If you can solve any of them in polynomial time, you can solve all NP problems in polynomial time, because NPC is the hardest. If you solve this in polynomial, then obviously NPC can be solved in polynomial time. They are NP problems that are also as hard as any other NP problems. Now why is important? If any NPC problem is P, then P is equal to NP, and if no NPC problem is P, then P not equal to NP. So extra note, you have to remember this or memorize this. Every problem in NP is also, oh sorry, every problem in P is also in NP, because if you can solve it quickly, you can verify it quickly. So that's all for today. See you in the next class. I hope all of the concept we cover in the class you understand. If you have any doubt, you can write in the comment box, or you can see the video again. So most of the doubt I think clear if you see the video again. So thank you.